Hello, and welcome to this sections of the basic language of functions. Function is a procedure that give outputs, and the what's specific about what a function is that it must produce only exactly one output for each valid input. Okay, you can think of function as an app. I mean, we can say, what's a procedure? Well, think of procedure as an app. Okay, so here's examples. For example, here is what this app will do. Okay, you open the app and then it will ask you for driver's license number. So you're typing a driver's license number 1, 2, 3, 4, 5. Okay, and you punch the that it will produce output and will tells you who is the license holder. So in this case, maybe King Kong or something like that. Okay. So one input, but valid input, it produces exactly one output. Very important. You say, why one? Why not 2 or 3? Because one is the simplest case, and so we have enough questions about this particular case, and let's figure out just having one output first. Okay, then we deal with the multiple outputs. Okay, so this app then probably on your cell phone, if it's or some device, and will have a name, and let's call this app the name N for names. And then what does the app does is that if you enter the number 1, 2, 3, 4, 5, and this is the input, okay, and then what it produces is the output. The name will produce the name of the persons, or in this case, King Kong. Okay, so therefore, in this setting, this procedure is a functions. Okay, and so in mathematics, we usually use the name FGH for some abstract functions. Okay, and so like this apple color N, and notice we have these notations. N is the functions, and an X we represent the input, and what it produces is the name, is called the output. Okay. And here's a case where it's not a function, it's a procedure, it's an app, but it's not a function. What? Instead of producing who is producing the name of the license holder, it produces the names of all the siblings. So therefore, the license holders might have multiple siblings. Therefore, you have a list of names, different ones. That's not considered to be a function for names. I mean, you just want one name's output, then that's considered to be a functions. The set of the valid input of the functions, we call that the domain. So in the case, what's valid input? The valid input in this case for the app N is all number. Let's assume you will take 5-digit numbers for license numbers. So then the domain of this app is all 5 digits number. Okay. You typing 4 digits, you will say no good. If you're typing 6, too many, only 5. Okay, that all 5-digit number, we'll call that domain. Okay, that's the input, the device, the app will accept, the function will accept. Okay, now what does it comes out? It comes out names. What kind of names? And all the driver's license name, driver's license holder, driver's names, if you like, the ones that have license. Okay. These we call the range. You can think of as target. This is where we wind up at. Okay, this is the output. Okay. And function has many ways. We can represent functions in many ways. One simplest way is a chart. Okay, we can call these functions a chart or table. We'll call it T. Okay, and X is the input. Over here, that it tells you what the output Y is. So in this case, it's very easy to see what the chart does. For instance, the input is 2. And then the output is 3. So we will say in our notation, we'll say T of the input 2 will wind up with the number output 3. And so also it's a table, it's a function. So where do we see these kind of functions? Menus. If you go walking to a restaurant and there's no fast food, they have all the items and each one has a price. That's a function. It takes the menu items to the output, the price you have to pay. Okay. And the range in this, the domain and range. Domain will be all the inputs this function will take. Only these numbers. You're restricted because the table only lists these ones. Okay. If it's not on the menu, you cannot ask for the price. Okay. Domain is the column, the range, and it's the Y's. And also notice we can have 2 inputs wind up the same output. That's okay. It's like you have 2 items that wind up the same price on the menu. Okay. But not the other way around. Not one single item list with 2 different prices. Okay, that's not a function. We don't want multiple output. Okay. Another way to express functions shown on the picture. Say here are 2 functions. Okay. One's the black line, one's the red line from 1910 to 2008. Okay, all that. The bottom one shows the price you will see on the in the gas stations is 50 cents. Okay, and so that's nominal price. Okay, so the range, the domain is the years that's listed on here, and the range will be roughly from the bottom to tops, that strips with the black lines trapped in between. Okay, and so this is a function represented using graphically. Okay, so we can read out on the chart. So usually when you have a chart in size, and this is the information passed through by eyeballing and by the graphs. Okay, and so here is the adjusted inflation price, adjusted the $2007. How much would that correspond to? Okay, and that 50 cents becomes $1.85 basically. So we can express functions graphically, use table graphically. For us, most of the functions that we're going to have, all the functions we're going to have, mathematical functions are defined by some kind of formula. Most of the functions. It looks like these. Okay, these are 2nd degree functions. These are polynomial functions. F is the name of the functions. Okay, and X actually is a separate component. Okay, it's not multiplications. Okay, do not read these, do not confuse these as F times X. Okay, sometimes we shorten this function, just use its name F. Okay, and these are different. That's the input box, and that's the actual formulas, what the F does, and that's the output. Okay, so and input box holds what? The input box holds the input. What's the input? Well, here, suppose I put 2. Okay, can think of the input box holds the application form, and this time I'm handing the application to or process to be processed, these particular things. And what do? You replace everywhere in the formula that is X, you replace it by the input. So you copy these, you paste it into what the position of X is, and this all becomes 2. Be careful how you copy these exponents outside, so it becomes these. And then we calculate. Okay. So it becomes 2 squared minus 2 times 2 plus 3, which comes out to be output, therefore is 3. Okay. And for this particular formula, we can plug in any numbers, so the domain is all numbers. Okay. And so here are some examples. Evaluate by plugging -2, and it wants f. Okay. And the reason now we want to name different formula as functions at fgh because on a single page of calculations, we might be dealing with multiple functions. So to make things simpler, we make names for the formula for the functions. Here's we're dealing with the formula f. So f is up there, and it's asks to take input -2. So you copy the input, it pastes it with x's, -3 times that. So it becomes this calculation problem that I can finish it up, and that's going to be equal to 3. 6 minus 3 is 3. G of -2. Now you have to find the formula G on the page, and that's the other one. So you copy the -2, copy and paste, and copy and paste. Okay, and it becomes that. And be extra careful with the exponent. The exponent is not part of it. It doesn't go inside. I mean, that's why when you copy and paste, copy it with the parentheses. So we'll paste it. And so it doesn't interfere with outside items, symbols. And so these then becomes order operations. And this is going to square this is -4 times 2 times 4 is -8 plus 6, and it's again -1. That's y output. I can talk about both functions at the same time and make a formula using this f and g. So it's like a 2 character. I cannot interact with 2 characters. So it's asking, says, this one is kind of clear. It's asking you to take this result, subtract minus that result. Okay. F of -2, meaning take -2, put into f. We already did it. So I know what that is. And g of -2, I also did it. So therefore, I put the previous results slot into the positions. Then this is the calculations, and it's actually minus a plus, so it becomes so the answer is 4. I don't have to put in numbers. I can put in symbols because I can manipulate symbols. So for example, in this case, it's asking us to take a plus b, this entire parentheses, and dump into g. Okay, so it goes in the x, it goes in the x, and so it looks like this. This is the first step you have to do correctly. It's a slot that the replacement x input correctly into the formulas. Copy that carefully. Okay, lots of mistakes happen on those. Now, in these particular ones, and remember a plus b squared, that's going to be a squared plus, there's a middle term. That's why we have this problem here. Okay, to remind you, the squaring involved the middle terms. Then I'm going to multiply by -2, distribute to every one of these, and I won't bore you. So this is what you end up with. There's nothing to combine. So there's nothing to simplify in this case. Okay, expand is long things. Okay. And we can talk about comparing formula. For example, I can ask you when is f of x equal to g of x. Okay, so these are the two functions, right? And this is exactly what we do. We place them by their respective formulas, the functions. And then this turns into a second degree equation. Solve this second degree equation, we get plus and -2. Okay, so we can use language in these fashions. That's what I'm saying. It's very flexible, and the meaning is clear. And the function we will deal with, like the function equal to a number with it's called a constant function. The output is the same. Okay, for constant function, the kind of functions we are going to deal with a lot are polynomials. Okay, the first and second degree polynomial are particularly important. And so these first degree polynomial functions, the second degree functions, okay, and first degree are also called linear, L, and second degree Q for quadratic, okay. So names for them, sometimes convenient. And we also deal with the fractions of polynomials of these types. Okay. And when we talk about function, two things, when we talk about formulas, two things that we have to watch out for the domain is the first thing, if I have a fraction, the domain cannot be 0. Okay. So for example, if the question is what's the domain of these functions, and then the denominator cannot be 0. So if I ask for the domain, immediately I zoom in on the bottom and I throw away the numbers will make the bottom 0. Throw them away because they're no good. They will make the bottom 0. So you'd say 2x plus 3. So it shouldn't introduce 0. So x cannot to -3. The domain with everybody else is good except for -3. No path for -3. Okay. And the other things we will encounter quite often is a square root. You can only square root or even root 4 to 6, etc. Odd root has no problem. We can take odd root, third root, fifth root, and so on, of positive or negative number. That's fine. But even you have to watch out. For example, over here, the square root, you must have, or we must have, if we are only dealing with real numbers, if we don't want to talk about complex numbers, then we must have the radicand, which is these things down here, which is 2x plus 6. We must have these bigger than equal to 0. Okay, just this part. But take it out of root, put on an inequality, and that turns into an inequality problem. And when we did that, last sections. Okay, so if this is x squared minus 4, then the requirement is x squared minus 4 has to be bigger than equal to 0. Means what? Non-negative, positive or 0. And these we solve by sign chart. This is what the connection is, plus 2 minus 2, we can say it's going to be positive out here. So this is a problem for domain of that formula. You want the inside non-negative and do sign chart. In this case, it's easy. It's a linear. You solve for 2x plus 6 bigger than 0, x bigger than 6. So this will be x bigger than 3. Okay. Next, okay, we want to turn formulas into graphs. Let's say into so it gives us this visual information or geometry, quote unquote, the geometry of the formula. It's very interesting and important, and give us insight. Mathematics basically is interplay between the two, the algebra in the picture and the symbol back and forth. Okay, and solve problem in that manner. Okay. For instance, if you think about how to go to get at some point to another point, a lot of people think of maps. Instantly, the picture comes up. Same thing, math. We try to get the most out of that. Okay, visualize and compute. So here's how we change graphs, formula or function into graphs. For example, here is the function x plus 1, and we plot them, and we set a bunch of input x0, x1, x2, then its output y is 1, 2, 3, 4 respectively. Then we plot them as points. Here, 0, 1. I mean, I could have put them horizontally, so it looks 1, 2, 2, 3, and 3, 4. Okay, so these are the x, y, and we put them, line them up, and not line them up, we'll plot them and see what kind of pattern they could produce. And these times they are linear, so they line up. First degree equation are linear. Okay, if we plot any formula of the form, like from the 3x plus 4, it's going to be a line. Okay, any ax plus b, it's going to be a line pointing one way or the other. That's why we call those linear functions. Notice for each input x equal to 2, y is equal to 3. There's only 1 point for one x produced, because one single x produce one single y. Okay. Now, if we blur who's the input, who's the, well, if we, these are called equations, that is, it's not written as a formula in x, okay? Rather, it's just a formula defined by the two symbols x and y, for instance, x equal to y squared, okay? Now, this is the procedures, and so I can suppose I use x as inputs, then we have a problem here. It's not a function. Why not? Because if I'm putting x equal to 1, x equal to 4, let's say, okay? And then I get 4 is y squared, then what y can be? Y can be 2 or y can be -2. And suddenly I got two numbers associated with 4, the output y, okay? And this is not a function. And when I plot them, notice for a single x, there are two different points that's on the vertical line defined by the x. In other words, they have two different outputs for the y. And so this parabola pointing sideways, therefore, is not a graph of a function. And in general, we have this function test of a graph. That is, if you have a line, vertical line passes the graph pictures at 2 points, then the graph didn't come from the functions. Okay, so if I have a graph that looks like this, and we draw a line, and there are multiple points on that vertical line, then this didn't come from a function. This didn't come from a formula of this type, y is equal to f of x, not a graph of a function. Okay, it's a graph of this type equation with letters mixed up. Okay, so these are called the vertical line test. That's it. Okay, do homework. Bye-bye. Stop here.